Hey everybody, this is Mr. Bells here. Just wanted to give you a heads up. We're going to start on section 2-5 from the geometry textbook for Geo A. And this information is really starting, you know how we did in 2-4, those algebra proofs, and we kind of stated why things work. So this one's working towards geometric proofs and proving statements about segments and about angles. I'm going to kind of take you through the book a little bit too as we go here. So one of the things that you're going to want to do is all of these statements, these postulates, these definitions, all of these things, you're probably going to want to have just a section in your notebook or a section on some separate pieces of paper of listings of all of them, because we're going to start to use those like a big old honking toolbox. So let's say you're working as a construction person building a house, and you kept all your tools in your truck, okay, or maybe at your place of work. Well, it doesn't do us any good, right? If we're at the house that we're trying to build and you need a drill, and you got to walk all the way back to your truck to get the drill, and then you come all the way back, it's kind of wasting time. If you needed a hammer and you got to walk all the way back to your truck or you're back to your place of work where your business is at, it doesn't do you any good. So we want to have all of these tools per se right readily available for us all the time, okay? So we want a toolbox. We want a big old honking toolbox full of theorems and properties and postulates and definitions and all those things so that we can pull those out and use them when we need them. And again, just a listing of them, but kind of know what each one of them is. So let me start with one of the geometric ones and see if you guys follow through. Okay, so I'm going to start, this is exploration number 1 in your textbook. And you can have your book open if you want to be able to use this, and I'm just going to kind of talk through this. So it says here, this is called a 2-column proof, and we're going to kind of start using a lot of these 2-column proof ones. It says, given AC is equal to AB plus AB, so that was given to us. So lots of times they're going to throw information at us in the very beginning and say, hey, we know this is true. Kind of like in a court of law, when some people submit evidence. These are things that we know are true. Now we've got to use that evidence and other information to be able to prove something. So when they say AC is equal to AB plus AB, that's what that statement says, and they simply justify it or give a reason as given, okay? This next one says AB plus BC is equal to AC. And you're like, how is that? It says that AB, this distance, plus BC, this distance, is equal to the whole thing. Well, awesome. If you go back in your list of different stuff, there's something called the segment addition postulate. And that's a postulate that says if I have a segment here and a segment here, and those are on a line, that means that those two segments individually add together to equal the whole thing. And maybe that's a distance of 5 and that's a distance of 7, just making that stuff up. There's nothing in this problem that says they're 5 and 7. But that the 5 here and the 7 here means that the entire length must be 12. Okay? So step number 3, now they're giving you this new statement. They're saying that AB plus AB equals AB plus BC. And we're like, how did we get that? Well, there's got to be something specific, some reason, some justification that we can make for that. And you'll see right here, I'm going to kind of show you this. You can see that that equals AC. And you can see that this equals AC from the previous 2 statements. So if both things are equal to AC, then we can use the substitution property, to replace one with the other. The other thing that you could also call this, and I'll accept it for any of these things, is we can use transitivity, right? If one is equal to another and the second one's equal to a third one, then we can set those things equal to each other. Good deal? So now this last one says AB equals BC. So my question is, how do I get from this statement right here to this statement right here? There's got to be something that allows me to be able to do that. And I'm hoping, if you look very carefully, that if I get rid of this and get rid of this, you'll see that my next statement, this AB is here on the left side of the equation, this BC is here on the right side of the equation. And you'll be like, oh, I really just did, right? Subtraction property of equality. I subtracted AB, I took AB away from both sides of that equation in number 3, and it becomes the equation in number 4. Okay? So that's what a geometric proof looks like. And again, we are just giving reasons. The other word that I've used for this, because not most, but a lot of other textbooks use conclusions and justifications. And I've used multiple textbooks over the years. So if you hear me say justifications, that's the same thing as a reason. And we're just looking for things that will make this true. And again, the only stuff that can go on the right side over here, it's not IDK and it's not maybe stuff. It's theorems, properties, postulates, definitions, given, so facts, things that we know are true or that we can prove are true based on the other things that we've done. Okay, so let's do another one right now and see if this helps you guys out a little bit. Let's do this one down here. Here's the information. It says given measure of angle 1 equals the measure of angle 3. So these two things are equal. And we want to prove that angle EBA, that's this big one right here, that EBA and CBD, that's this big one right here, that those two things are equal. And I'm hoping it's common sense in the beginning, right? If this is a dot, right? If 1 plus dot equals something and 3 plus dot equals the other one, and 1 and 3 are the same, then we're just adding the same amount to both sides. That's just my quick little thing, but we're going to try and be very precise in the way we put information down here. Okay, so we're going to try and fill in these blanks. We're going to try and fill in the left side based on what they say on the right side. So let's try it first. So this reason was given. Well, the only thing we can have that's given is what's given. So I simply can put the measure of angle 1 equals the measure of angle 3, because that's the only thing in my statement that was given. Is everybody okay with that? Next, they say that EBA is equal to angle 2 plus angle 3. EBA, that's this one, right? Is equal to angle 2 plus angle 3, and that's called the angle addition postulate. And that's something that we had before. Like I said, that needs to be in your toolbox, your big toolbox of all these theorems, properties, postulates, definitions that we're going to be able to use in this thing. Then this one says that angle EBA is equal to the measure of angle 2 plus the measure of angle 1. They're like, why? Why can I do that? It says 2 plus 3, now it says 2 plus 1. How can I just randomly change the 3 to a 1? Well, I can do that because of step number 1. Step number 1 says that 1 and 3 are equal. And the substitution property equality says any place there's an angle 1, I can replace it with an angle 3, or any place there's an angle 3, I can replace it with an angle 1. And that is what we did. We replaced that angle 3 with an angle 1 and justified it, or made a reason that I could do it because of that. So the next one says the measure of angle EBA is equal to blank because of the commutative property of addition. And you're like, well, what the heck is commutative property of addition? Commutative property of addition says that if 3 plus 5 is the same as 5 plus 3. Okay, so that means that right up here, that if I have angle 2 plus angle 1, I can also write it as the measure of angle 1 plus the measure of angle 2. Okay, so then down here, it says the measure of angle 1 plus the measure of angle 2 equals what? 1 plus 2, adding up 2 angles should equal the bigger angle. So we're going to put the measure of angle CBD. That's what the angle addition postulate says, is that if I have 2 adjacent angles and I add them together, it's equal to the bigger angle itself. Okay? So now this one's always going to be super easy, or at least I hope for us. My last step in my proof should be what I want to prove. Okay? So now the question is, why am I able to make that statement, right? You know, kind of like closing arguments in a lawyer's case. It's like, this is why they're guilty, bam, bam, bam. Okay? So how can I put that there? Well, I know that it's got to be that measure of angle EBA is equal to the measure of angle CBD. That's my, lost that, CBD. Why am I able to write that? I'm hoping that you guys can see this between these two expressions right here. EBA is equal to 1 plus 2. 1 plus 2 is equal to CBD. through the transitive property equality, and also I would say that I would accept substitution on this one if we needed that, because I'm just replacing the EVA in the angle 1 plus angle 2 expression. Okay. Slight difference on that is substitution usually is one thing equal to another, not one thing equal to a sum of things. That's why they use transitive property of equality right here. Okay, so hopefully that's at least a great start as we go through some of these other things. They're gonna give you examples, and you really need to be able to write these things out for them. There's going to be theorems, awesome theorems. So I'm going to talk just a minute about a theorem and what a theorem is. So a theorem is like building a new tool. So like if we had, tweak that a little bit. Camera's spinning on me here. If we had the need for a different screwdriver, we don't have another screwdriver, maybe I'm going to build myself another screwdriver. A theorem is kind of like that. So a theorem is something that we're going to be able to prove based on pre-existing postulates and definitions and other theorems. And as we go through, we're going to keep adding more and more things to our toolbox. But that's what a theorem is. Okay, so one more time, big picture. We started off with 3 undefined terms, point, line, and plane in this geometry class. And then we had postulates. Postulates are things that we assume are true based on just looking at the situation. We're like, yeah, that should be true, or we're going to at least assume it's true for what we're going to talk about now. Okay? Now we've got definitions that we're defining things to be certain things. And now we're getting theorems. So we're going to get stuff, information out there that we're going to prove, and when we prove it, if it's useful for us, we're going to call that a theorem. And that theorem we can now use in all of our proofs. And I know you're probably like, your head's spinning like, dang, Mr. Bells, can't he just do like 3 times 7 in this class? I think it's an important part of learning, but it's a different way to think about stuff. So stay with it, be patient with it. Know that you're going to mess some of the questions up on the online homework, but we're going to still keep plugging and chugging along. Okay? So, here are some of those. Here. So, we have reflexive, symmetric, and transitive. Reflexive, symmetric, and transitive. Now, the only difference is, because you're like, Mr. Bells, we already knew these 3 things. These ones all have congruent symbols in them. Congruent symbols in them. All the ones that we got before were equal signs. So what's the difference between an equal sign and a congruent symbol? Technically, you can go from one to another by something called the definition of congruence. But if I was thinking about something, and let me draw it on the piece of paper right here. I have these 2 segments right here. Make it here. If I have this as AB and this is CD, then I can say this segment AB is congruent to segment CD if I had little tick marks, okay? But the distance, right, if we don't put a dash over the top, then we're talking about a distance, an actual numerical amount, that AB is equal to CD. Like this might be length 13 and this might be length 13. We can say that the 2 segments' lengths are equal. Their shapes as segments are the same. Their lengths are equal. That's the difference between congruent symbol and equality symbol. And if you mess it up and you put one in place of the other one, again, I'm going to be really lenient, so don't stress about that. Don't worry about that. Those are those 2 things. So again, how do I justify going from one statement to another statement or back again? That's going to be another definition that you're going to put in your big toolbox of knowledge. Definition of congruence. Definition of congruence states that if something's congruent, then it's equal. If something is equal, then it's congruent. We call that, right, biconditional. Biconditional means that it can go both directions and they are both true. Okay, flying back to the sucker right now here. So as you go through some of these ones, and we'll do them in class too, we'll give certain examples. So make sure you have your where is it? Let me show you again. This sucker, your geometry student journal. Make sure you have one of those things, because that's what we use to write a bunch of the stuff out. Now, this would be an example of a two-column proof, so they're going through it. And one more time, what does a two-column proof look like? Two-column proof starts on the left side and makes a statement, and then on the right side, you got to just say why it's true. So if M is the midpoint of AB, why? Why do I know that? Well, it's given. Look, right there. They gave it to me. My end goal is to prove this stuff, so that needs to be my last things that are going on here. And then all of these steps that I do down the left line is kind of like building up why I'm able to say these at the end. And I give my specific reasons for each one of those things on the right-hand side. Okay? Important to come to class to see all those examples. B, to watch these separate videos that you're doing right now. C, to actually, I know some of you don't ever do this, but read in the textbook. This will help some of you who are struggling with it. All of those things will help us with the homework that's online. Again, quizzes are going to be the basics of all of these things, or at least I'll have some easier questions, some medium questions, and maybe a couple ones that are a little bit more difficult. Stay on top of this, believe in yourself. If you need extra help, make sure you ask questions and come see me. Okay, I'm out. That was Geo A 2-5.